Cześć i witam wszystkich. Hello, welcome back to another STEM Racing Poland webinar. Today, I am joined by Laurence, who can introduce himself and the topic we'll be discussing today.
Hi everyone. So I'm Laurence. I took part in F1 in schools myself back from 2017 to 2019 with my team Centurion Racing. Since then, I've been on to go and study mechanical engineering at university. And in September, I'll be starting a job as a stress engineer at Williams F1 team. And that also was partly due to the Williams Engineering Academy that operates through the F1 in Schools World Finals. In fact, STEM Racing World Finals. I'll have to stop myself saying that.
Definitely going to take me for a while.
Indeed, indeed. And you may have also seen me a few times at STEM Racing events, because at UK and World Finals, I've been a tech pundit. So before races, I've kind of given my opinion on, different features on the competing cars and who I might think will win. And also in those years since I've competed, I have judged almost every element of the competition. So have a little bit of the experience in that field as well. So if we dive right into it, for my team, I was the design engineer. So as well as kind of managing, I was the team manager too. So I was managing all of the other things that were happening, but I was actually responsible for delivering the car and the design and engineering portfolio myself. And through the time I took part in the competition, I made all of the mistakes that there are. The first time we were there, we had a car that was barely legal. It failed so many regulations. But then even through the next years, little things kind of caught us out. There are these things in the regulations, we'll talk about them later, performance regulations. If you break one of those, you're ineligible for the fastest car award or the best engineered car award. I know we were prevented from being national champions in 2019 because we'd broken one of these regulations, as well as actually quite a lot of teams. I understand the team that won in the end was around 7th or something in points. So that kind of takes me on to one of the topics I'll broach earlier, which is scrutineering and how it's super, super important that you guys have a legal car. Anyway, when I'm at competitions, talking to people, a lot of the time I'm there is spent saying, it's not just about the car. It's not just about the racing. Obviously, that's what is kind of the most exciting bit. And it's what you get to see on the live streams. Like you don't see the engineering interviews happen. You don't see the verbal presentations. However, while it isn't all about the car, the car is directly worth 41% of the points at World Finals. That's for scrutineering and racing, and an additional 18% if you include the design and engineering judging. So while it isn't everything, it is a large amount of the marks that revolve around the car. And also, the best teams, the teams that at nationals will progress to worlds, or the teams that will, reach the podium at World Finals, they're really good in every single one of the 6 main categories. So, being strong in the area of the car is super important. Now, the number one piece of advice, actually, which is true for every single judging category, is read the scorecards. Like you're providing them, and it's like you've got the answer sheet for the exam paper. You're told exactly what they want to see. So if you're including any information for anything that isn't included on the scorecard, great. Maybe if it really impresses the judges, it'll kind of make you a candidate for the Judges' Choice Award. But it won't get you any points, which contributes to the overall finishing position. So the scorecards are super important. And when it comes to the scorecards for the cars, that is mainly the technical specifications.
I think Laurence cut out there for a second. The Polish technical regulations and specifications can be found on the stemracingpoland.pl website. We're going to be there. There are own versions. Make sure you're not using the international ones or the English ones, they're probably going to be the same. They're very comparable regulations, but just make sure you're using all regulations on the stemracing.pl website. Otherwise, there might be some small problems. Laurence is gone. You've been left with me. All right. In that case, we can have a look at the STEM Racing Poland website, actually. Let's try screen share. Screen, understand. There you go. So if you go onto the STEM Racing Poland website, stemracing.pl, we go down, lots of interesting things to read. This is where all of our webinars are, but down here is where this specific webinar is talking about. This webinar, we'll be looking at the technical regulations. I need to change my screen that we're showing. We'll give it a second to load. We'll give Laurence a second to rejoin. Seems that his internet has cut out. But here we are, STEM Racing Poland technical regulations. So this is, I liked Laurence comparing this to an exam because it really is, the regulations really are both an exam where you get to see the questions beforehand. You know what the judges are looking for. You know what parts of your car will be assessed and what part of the whole competition will be assessed. And it also has the answers in here. You can go into, we'll try to find some specifics about the car. And it'll tell you what's a mandatory rule to let you to race. It'll tell you what a performance rule is. So if you break any performance rules, you'll get small penalty races and won't be able to qualify for rewards if you end up doing a race. And here we go. Stuff like this. You know, you can turn up to the competition, and if you've read the regulations, you know exactly how much your car needs to weigh and the penalties are if it doesn't weigh that much. So it really is worth looking at the regulations. But I think Laurence has rejoined. Welcome back.
Indeed.
The English.
Sorry about that.
Okay. No worries.
The English Wi-Fi isn't very good. No. So, where?
That's very unfortunate. Let's go back here. I think Laurence is definitely having some troubles. He should be back in a second. Hopefully.
Have you got me?
I think so.
Good. Let's hope it lasts. Where was I when you lost me?
Talking about the regulations, and you were ending the conversation about how it was basically an exam where you know the answers and you know the questions.
Absolutely, yes. So that applies to all judging categories. But then when you get to the car, I mean, with all of the other elements of the competition, you know, the racing, the design and engineering interview, the verbal presentation, they all have a live element. You know, you can always have a bad day on the competition and it can go less well than you'd hoped. You know, so there's, let's say, a little bit of risk in all of those marks, however well you've prepared. However, with the points for scrutineering for your car design, 100 points, you can guarantee those points before you ever arrive at an event. You know, it's really important that you design your car to be legal, but even if there are some problems in manufacturing, it shouldn't be a surprise to you because you can measure them before you get there. Like, I think the scrutineering tools that the scrutineers use, you can download those files to laser cut them yourself, but really all you need is a set of vernier calipers and a set of scales, and then you can do most of the scrutineering yourself. And in the kind of design phase, I mean, I've been there myself, and I've also heard a lot of other people talk about it. You can kind of reason with yourself, oh, but if I broke this regulation, I'd get this much performance advantage. And I can promise you that that is never, ever worth it. It's not worth the performance you'll get, because I think you'll find that actually that kind of change will be a very marginal gain on performance, if any. And yeah, it will make you ineligible for best engineered car, ineligible for fastest car, and you're going to be unlikely to win the scrutineering award too. Just don't do it. And
So
guarantee
you've been
you're
to events.
Go on.
I was just going to say, you've been to events and you've heard people like discuss breaking a specific regulation in trying to increase performance somehow.
Absolutely. They've been, we get a 10-point penalty for breaking this rule. However, we think it'll give us 0.05 of a second, which will give us more points than that 10. It's such a risk, and it's one that's, honestly, from experience, thinking about these things myself and then seeing it play out at countless competitions since, it's never worth it. Don't do it.
Good advice.
Absolutely. So if we go on from making your car legal, I can bang on about that all day, and then talk about how to make your car fast, or not just fast, but perform well in terms of the racing. Because the kind of the first thing, and it might seem obvious, but it's again one that occasionally gets overlooked in car design, and that is impact survival / like the reliability of your car. Because the scoring isn't just based on like the one fastest time you get. The scoring is based on the average of your second and third fastest times. So for that, it is really, really important that you get 4 times in there that are as good as possible. So, any races where like a wheel falls off or any part of the car falls off before the finish line, that time will be excluded, and you'll have 1 less attempt to get a really good time on the board. Obviously, that has been greatly improved now the Halo's been introduced. Chances of breakage are much less. But especially with the Halo, say, when you're 3D printing it, it's really important that the quality of the print around the vertical strake of the Halo is really good. Because sometimes the layers of 3D printing can peel apart and make the design weak in that area. And, if your design was to go straight through that deceleration system, which again, we probably see 1 car every competition do that, it'll fly to the back and, do potential damage to it. So really pay attention for the survival of your car to make sure the quality of your Halo is really good, and the quality of the bond of the Halo to the rest of the car is good as well. Because we've also seen Halos fall off cars. And yeah, you don't want that to happen.
That's a very good advice.
Now,
I've definitely seen cars suffer there.
Yeah, no, for sure. These are kind of the things we've covered so far, the scrutineering, the survival and reliability. They don't actually make your car faster at all. They don't make it slower either necessarily. How they do allow you to score the points, and ultimately the competition victory doesn't necessarily go to the team with the fastest car. It goes to the team with the most points. But then in terms of lap time, it's not quite a lap, but anyway, the most important thing is mass. Being right at that minimum weight limit for your class, which development class in Poland, that's 60 grams. To be really competitive, you need to be kind of within 0.5 gram of that. And that's always 0.5 gram above, let's say, because if you're below the 60 grams, any amount that you're under that, you'll be given double the amount in ballast. So if you're coming in weighing 59.8, the scrutineers will make your car up to 60.4 grams. And you might think, that's not so bad. but it is also still a performance penalty. So even though your car is heavier as well, you'll still not be able to win the fastest car award either. But being on that minimum weight is super important for time. And, you know, reasons that teams say don't make the weight is sometimes it can be parts turn out heavier than you expect. And a really common one is when you paint the cars. You know, the F1 in Schools model block, STEM racing model block, is an extremely porous material. It takes in a lot of moisture, so you can find you paint it, and the car just gets heavier and heavier and heavier. So it's always important that before you finish your car, you're under the weight limit to allow space for that. And, you know, while you're making prototypes, always a useful thing to weigh the car before paint and weigh it after. Because then even if on your first one, you know, you go from 55 grams to 65, you now know that you need to leave 10 grams free for paint. So you need to make that car weigh 50 grams before you've painted it, for example. You can approximate this through CAD, your computer-aided design tool that you're using to design the car. You'll find that you can apply material properties to elements, and then based on the material density and the volume of the part you've designed, it'll tell you what mass the part should be. Now, you know, this will never be quite exact. However, it will give you a good indication of what the weight of the car should be. So you'll know if you're, like, you know, very overweight or equally very underweight, because it can be quite difficult to ballast a car up to make it legal as well if you've got a light car. At least for my team, it was always our object to be as light as possible before paint, because then, you know, if the more and more mass we saved, the better and better finish we could have. You know, in the end, for our national and world competitions, we ended up using automotive paint, which is quite heavy, but it gives like a super glossy, shiny finish that, you know, made all of the seams between like the model block and the 3D printed elements, it made those seams completely smooth. And there are points for the finish of your car as well. So, you know, any mass you can save, you can use to get a better surface finish, potentially.
That's cool.
There is another thing on mass, as well as kind of outright mass. Like that's the number one thing you should aim for in your design after legality. But you might want to think about where you have your mass in terms of height, let's say. Because at the back of the car, it's quite high up. You've got the CO2 canister. And, you know, you'll have most of the mass of your car below, like all of the wheels on the ground level of the car. I've actually got one of my old cars here. So you know, all of the wheels and everything quite low. You've got this mass up above the CO2 canister. This means the car will pivot around its mass based on where the canister is. So when the canister explodes, the car will actually nosedive into the track, and you're losing energy there. You're creating an additional frictional force on the front end of the car, and you're essentially spending this finite amount of energy that every team has in the CO2 canister to go down rather than forwards. So, you know, it's really important. Everyone has the same mass of CO2, and it's important that you use it to go forwards, not left or right, not down, not up. And we will talk about some of those other things a little later as well. But yeah, you might want to consider having your mass a little higher in the car to kind of get the center of mass of your car in line with the CO2 canister.
Makes sense. Also
important to say, you know, it's often that teams would consider the mass of their car without the CO2 canister. And, you know, you've got your F1 in Schools STEM racing car that weighs 60 grams, but then you put a canister in the back that weighs 20 grams. So that has a massive impact on where the center of mass of your car is. So certainly not one to overlook. And it's one that if you consider it, the judges will be impressed. Then the next point on performance is build quality. Now, you might kind of overlook this as well, but you can design the fastest car in the world, let's say, on your CAD software. But then if you don't build it well, it won't be very fast. And the most important thing is ensuring all of your wheels are in line. The STEM racing track is a 20-meter straight line, a drag strip. But, as soon as you have a little misalignment between your front and your rear axle, the car is now designed to go around a circle instead of down a straight line. And, in kind of the least bad cases, this just means the car will look like it goes down the central track, but you'll be losing that bit of energy in the additional friction with the wheels at an angle. But then in the worst cases, you'll see a car going the whole length of the track actually down one of the sides of the track, and it'll lose a ton of speed the whole way. So super important that you get those two axles perfectly parallel in the car. Worth mentioning in terms of that, wheelbase. Wheelbase is the distance between your front and rear axles, and the shorter the wheelbase, the kind of more difficult you're making your life in terms of getting those axles aligned. Because if you imagine a really short wheelbase car and one axle is out by 1 degree, you're going to have a car that goes around quite a tight circle. But if you have that same 1 degree error, but over a long wheelbase, it's going to become a large circle. So in terms of minimizing kind of any negative effect there, it's impossible to get those axles perfectly aligned. Only in the CAD world do we have measurements that are 1.0000. However accurate you are in the real world, you're going to come to a 1.000 something at some stage. So, in terms of that axle alignment, having a longer wheelbase car is a bit of a safer choice there. You're making your life easier. Then the next one, and this is probably the point that is talked about actually most, because it's the most obvious thing to see, the most easy thing to look at and talk about, that with STEM racing or with Formula One or any other kind of racing, and that is the aerodynamics of the car, the shape of the car. And the aerodynamic drag that your car experiences is a product of two things. It's a product of the drag coefficient, and this is a unitless number which is defined by the shape of your car. The smoothness of the sides or just any features. And so it's a product of drag coefficient and frontal area. And frontal area is if you take your car and look at it perfectly front on, as I try and line this up with the camera, what is the surface area of that front? You can imagine, if you shadow puppets almost. If you were to do that with your car and look at the amount of black area you get, you can measure it on your CAD. That's the frontal area of your car. Now, my advice when it comes to that, because of the drag coefficient, it's always a bit of a kind of dark art, let's say. It's quite hard to optimize your drag coefficient, and it's also very difficult to be confident in the values you get, because to realistically represent your car in the CFD, you need to get so many different elements working. The most simple CFD, computational flow dynamics, that is, kind of renderings of an F1 in school STEM racing car will be in a kind of rectangular section tunnel, and you'll have air coming in one side, going
Oh, it seems we've lost Laurence again. He's fighting his best. He's trying so hard. Let's see if Laurence's Wi-Fi can stabilize for us. Seems not. Thankfully, I have the regulations up now, so we can have a look. Oh. But this is what Laurence was mentioning, that you have the size of the tools that the scrutineers will be using. Are you back with us?
Oh, do you see me again?
Yeah.
Lovely. Fantastic. So yeah, I was talking about the drag coefficient of your car, kind of how it's potentially a kind of difficult thing to improve and at least very time consuming. Drag coefficient decided by the shape of your car, the form of your car, and how you'd look to optimize this would be either in a physical wind tunnel, although it can be quite difficult to get readings out of a physical wind tunnel, or in a virtual wind tunnel, and this is known as CFD, computational flow dynamics. Now, kind of the accuracy of those results is questionable. Most likely, to be honest, you can get useful results by comparative testing. This means the actual number might not be that realistic to what it is in real life. However, if you make a change that is negative, you'll still see that number get worse, or a positive change and it'll get better. And kind of the most simple way of doing this is if you imagine having your car in a cuboid section, so like a long rectangular section with your car in it, and you'll have air flow on one side and air exiting on the other. And most people go for a wind speed of 20 meters per second. This is imagining if you got your time, kind of to the golden 1 second time. However, that time isn't very realistic with a professional class car. And it's also, definitely a dev class car, you're probably looking at times closer to 1.2, 1.3 seconds. So you might want to adjust that airspeed and make it a bit lower. But you can get some good results from that. But then you can also spend lots of time adding complications that do make it more realistic, but, might be a loss for you in terms of, the time you could spend doing other things that would gain you more points. The first thing that kind of judges would look to see in terms of CFD simulation is, do you have the wheels spinning? Because that's, a super important thing that affects flow around the car. The wheels spin, generating a lot of turbulence. They actually generate a bit of lift as well. So accounting for that can make a big difference to how your car performs aerodynamically. But then other things that you could include that will make a difference is, including the CO2 canister in that and the outflow of air behind it, because that will suck air around from the rest of the car. And also, rather than using a rectangular section for your wind tunnel, you could actually use the track sides, which are, angles that are a bit closer to the car, and they will also affect the flow. But that is adding a lot of complication, a lot of time, and I don't really rate that kind of as value for money development. Formula One teams look at how many pounds it costs to get a tenth of performance and will invest their money in the ways that will get them the best return on their investment. And you guys should be doing the same thing, because you're balancing your education at the same time. You also need to have a life outside all of this, even though this is obviously the best thing to spend all of your time on. It's always worth looking at kind of what is the easiest way to get performance. And that's where we come onto frontal area. There's no kind of black art to this. There's no, we can make this tweak, but we're not sure if it'll make it better or worse. Frontal area, the smaller you make that, the less drag you'll have. So I really advise people to look into that. And that is, you've got these defined areas of your car, like the wheels have their minimum diameter and minimum width. In fact, in development class, they're a standard wheel, so they're the same for everyone. You've also got your no-go zone. However, if you make it so your wings align in front of your wheels, they're not adding any extra frontal area to your car. But if they go wider, or if other parts of your car do, you're adding more frontal area to your car. So, sometimes that'll be beneficial for you, but you should always try and justify that to ensure it is for a positive reason. Because if you don't know why you're adding frontal area to your car, you shouldn't do it, because it's a negative on the performance. Then finally, is kind of looking at the other losses on your car, and these are usually friction losses. Now, in the professional class, you'd consider making your own wheels and also bearings. However, these are things that your team might consider if you get to the World Finals. However, in the national finals, you'll be making development class cars, so there are kind of two factors here. One is that the wheels spin freely, and this is one of the things that is a massive source of pain for me when scrutineering dev class cars, because you've got those standard wheels, standard axles, and when you're assembling the car, you tend to push them on as hard as they go, absolutely. However, sometimes that can make the movements really stiff. So it's a super obvious thing. I'm sure most teams do it, but always kind of have a little tweak of those wheels and axles and just check how they spin on the car, because there is a lot of performance in that to make sure that they do rotate freely. And it's
cars
a
not
completely
roll
free
and
thing to
instead
do.
it's right to the end.
Absolutely, yes. And this is something that'll take you less than a minute. So really worth looking at that. And the other thing are the tether lines. They're on the car for safety, so the car can't take off and hurt someone. But they're essentially a brake on the car. Now, in the regulations, there's this mass that's hung off the tether lines. If the tether line comes out of the car, you'll get penalised and a new one will get put in, because for the car to be safe to race, that tether line has to be secure. However, while ensuring that the tether line guide is secure, I'd say it's worth looking at making that hook as low as you're allowed to make it. Because the further it's screwed into the car, the higher it is, the higher it will be lifting the tether line off the track, and the more braking force you're going to have from the tether line. So the lower you can make the tether line eyelet while being legal. I mean, there isn't a rule on tether line height other than the ground clearance of the car. So that number has escaped me. It might be 2 millimeters or something, but you should definitely have it down at the minimum ground clearance of the car. Because again, it's kind of free time. Indeed.
Lots of useful advice.
Thank you. Indeed. I hope you kind of consider all of those things. Now, just a few more tiny points to kind of go with that is, I've mentioned kind of areas, but as within real Formula, you can't have all of it. There's always going to be a compromise, let's say, for some things. So I'd really encourage testing to find out, we call it sensitivity testing, to find out how important all of the different things are. So if you're able to make yourself a bit of a modular car that you can adjust, maybe you can put different wings on it, or you can, just put different masses on it, even in as simple a way as, a bit of blue tack. You're then going to be able to test a few things back to back, knowing that the testing cases are as close as they can be to being fair. Things that you could do, you could test your car with a flat rear wing with no angle of attack, and then you could test it with a really, really aggressive angle of attack. Then you can see, there's a difference between runs of 0.05 seconds kind of consistently. And in our virtual testing, we can see that between those two designs, there's a drag coefficient difference of 0.1. And now you immediately know that, okay, a drag coefficient value of 0.1 equals 0.05 seconds of on-track time. You can quantify that benefit. And the same thing with the center of mass. You'll probably do one run with mass as low as possible, maybe get a bit of blue tack under your car, and then one mass, plop it right on top. See what the difference is there. And then you're able to see, okay, there really is this big benefit from getting my mass higher on the car. And you can say, actually, that's bigger than the aerodynamic benefit of having, my really steep wing versus my flat wing. And, even though you're never going to use that steep wing, it shows you, okay, so I should prioritize working on how I can get that weight higher up rather than prioritizing the aerodynamic shape of the car. Things like that. And these are the things, actually, the design and engineering portfolio, it's not directly, influenced by the car. You could turn up without a car because you've struggled to make one, but you can still have your design and engineering portfolio. But it really feeds from the car. And to be honest, all you need to do to make your design and engineering portfolio simply is record everything that you're doing to design your car. It's so easy to kind of do things without making notes and then I can't remember quite what that number is or quite what I did there. So it's really important to be kind of methodical with your process, really record the steps you went through and your thinking behind it, so it can go in the design and engineering portfolio. And the testing is something that really kind of impresses judges as well, because it adds evidence, justification for the things you theorize about before. In the design and engineering portfolio, you don't get any points for guessing what the fastest car design is. You get points for using a solid kind of scientific principle and then process to go and work out what the fastest car design is. And it's worth pointing out, actually, that the design and engineering portfolio, it's completely independent from the car. You can have the slowest car on track. It can come last. It can DNF every race. It doesn't stop you getting the best marks for the design and engineering portfolio. I mean, it's one of the things that happened at my World Finals. For whatever reason, our car, sadly, wasn't the fastest in the world. Sad face. From 55 teams there, I think we had the 31st fastest car or something. And, it wasn't massively far off, but it was also a really, really close field. However, the process we went through and kind of how meticulously we'd recorded it and justified the decisions we made, inspired confidence in the judges. And as a result, we got the Research and Development Award. So, you can still do really well in design engineering without a fast car. And kind of leading on from having a slow car but can still do well in design and engineering, if something goes wrong for you, don't kind of try and wash over it. Include it in the portfolio. What went wrong? Even if you haven't been able to fix it by the time of the competition, there are lots of marks for the portfolio for evaluation. So, we did this, it went wrong, but we've identified it, we've learned from it, and this is the action we're going to make so it doesn't catch us out next time. And that will get you loads of marks. I forget whose quote it is, but famous racing quote, it may even be Niki Lauda. And that is, you learn nothing when you win, but you learn loads when you lose. So, having those things go wrong for you, make sure you include that because, you can get points for it. Then finally, we've done design, we've done testing. We kind of, talked about manufacturing a tiny bit with the kind of painting of your car, just to include that you're not caught out by mass. However, one other thing on manufacturing that's really important, this goes back to the scrutineering and the legality. It's really important that when you make something, you measure it. You check, I designed my wing to be a 20 millimeter span. but I've measured it and it's actually 19.5. So you can identify that, okay, there was some shrinkage in the 3D printing process, and now actually I need to, before I print my part, scale it up by 1.1 times because I'm going to have whatever percentage shrinkage. Or, you may only notice that it shrinks in one direction, and that could be due to the orientation that you've printed it. But that allows you to account for that in your design. When you account for things like this, we call it tolerancing. And on a broader point, it's really important with the regulations that you do leave tolerance to all of the regulations. Because you could have a car that in the perfect world of CAD was, it passed every rule, but by nothing, to 0.000. It's exact. And a car that's designed that way will probably pass none of them when it's actually manufactured, because you'll have, all of the various tolerances of the manufacturing processes, whether that be 3D printing, whether that be the CNC routing. You then add a thickness to it. When you add your paint to it, everything grows a little. When you attach your front wing to your body, you will add a glue gap that might be 0.1, 0.2 of a millimeter. But, all of these things add up. At least when I designed my car, we left, say, a 1 millimeter tolerance to every regulation, except for a few ones that we decided were really kind of important performance-wise. And, that was always the professional class for me. So that would have been, these are different things to you. Important things there for performance were wheel width, wheel diameter. They made a massive difference, being right at the minimum. So rather than leaving a 1 mil tolerance to those, we might leave a 0.5 mil tolerance. And kind of the same with the mass. Don't go a gram over, you're throwing away performance. Maybe go 0.1, 0.2. But you really do need to consider tolerancing for everything. And it's another massive thing that'll get you points in the design and engineering as well, because something that the judges are really keen to find out is how do you know that this car that you've provided us is the same as the one that you designed? And that's all about understanding the manufacturing, the tolerancing, and all of that.
I've definitely seen lots of teams at events turn up and try explain themselves that in theory everything on their car was perfect, but then they left their car manufacturer a little too late, turned up on the day, and the car wasn't perfect.
Absolutely, yeah. So it's really important that you kind of think about that through the design process rather than making it a last-minute thing. But also, then you can self-scrutineer your own car with the regulations, with the scorecards, and just check, then there aren't any surprises. And, there are potentially things that, you could find that you can modify. Like, maybe you make the finish a bit worse by sanding a little bit of the body or a little bit of a wing. However, it'll still be preferable to lose a few surface finish, but wheel appearance. Indeed.
All right, well, perfect. Hopefully people took some notes. They took some advice from what you said. You've been to World Finals. You've been judging this competition for many years since, so you definitely know what you're talking about on this matter.
Indeed, mainly through making all the mistakes myself, as said initially, but hopefully I've made some of those mistakes so you don't have to. Indeed.
That's what we can hope here.
No,
well, whilst we still have you on the internet, we'll try to wrap this up cleanly so we don't have to end abruptly. Thank you for your time, Laurence. Thank you for everything you told me and told the audience. This video will be obviously uploaded on YouTube, so if anybody ever wants to refer back to this or just wants to show it to the rest of their team or something like that, that's where it'll be. All the regulations we mentioned today and how close you have to be and so you know what you're working with. As I mentioned, is on the stemracing.pl website, and you'll find our Polish regulations there. And I think that's enough advice for today. Now you've got to go apply that advice. Again, thanks for your time. Do you have any final remarks?
Yeah, well, best of luck to you all. And no, I mean, I would just say kind of best of luck to all of the Polish teams. I'd love to come and see your competition sometime, but I also really look forward to seeing the teams that come to the World Finals from Poland, and I'm really excited to see what they can do.
Perfect. All right. Well, in that case, thank you everybody for watching, and until next time.